discussion will be confined to the gases and liquids. So let us briefly discuss the points to be covered in the states of matter. So basically states of matter is divided into two parts. One is gaseous state, other one is liquid state. Now present to begin with, we start with gaseous state. In gaseous state, what are the subtopics that are to be studied? One is parameters of the gas. What are the parameters of the gas? Every gas is defined by 4 parameters. What are the 4 parameters that are used to define a gaseous state? Pressure, volume, temperature and mass. What are the 4 parameters that are used to define a gaseous state? Pressure, volume, temperature and mass. Mass of the gas is usually expressed in terms of number of the moles, and we have to study about the units to express the various parameters of the gas for pressure, volume and temperature and mass. What are the units for the pressures? In generally, pressures will be expressed in terms of either atmospheric units or bar units. What is the SI unit for pressure? Newtons per meter square. After studying about the parameters of the gas and their units, then we will go to the gas laws. What are the gas laws? What we'll study in the gas laws? What are the gas laws? We have Boyle's law, Charles' law, Avogadro's law. Mainly Boyle's law, Charles' law and Avogadro's law. And what is the importance in the discussion of the gas laws? Every gas laws are stated to discuss the relation between two parameters, keeping the other two parameters constant. For example, the relation between the pressure and volume, when mass and temperature are kept constant, is given by the Boyle's law. What is the statement of the Boyle's law? Pressure of a given mass of gas is inversely proportional to the volume of the gas at constant temperature. When N and T are kept constant, the relation between the pressure and volume is given by Boyle's law. So the relation between volume and temperature, when pressure and mass are kept constant, it will be given by Charles' law. The relation between volume and number of the moles, when pressure and temperature are kept constant, is given by Avogadro's law. So what is the purpose of the gas laws? Gas laws discuss the relation between the two parameters when the other two parameters are kept constant. What is the equation of state? We have P1 V1, equation of state connecting the 4 parameters. P1 V1 by N1 T1 will be equal to P2 V2 by N2 T2. When N and T are constants, what will happen? When N and T are constant, P1 V1 will be equal to P2 V2, which is nothing but Boyle's law. When P and N are constants, what will happen to the relation? V1 by T1 is equal to V2 by T2. When P and N are constant, what will be the relation? V1 by T1 will be equal to V2 by T2, which is nothing but Charles' law. Apart from this, we have to go for the ideal gas equation. What is the ideal gas equation? PV is equal to nRT. PV is equal to nRT. PV is equal to nRT. And PV is equal to W by M RT. W by M RT. PV is equal to W by M RT. What will be the W? PVM by RT. PVM by RT. What will be the M value? WRT by PV. WRT by PV. And what is the expression for the density? The expression for the density, D is equal to PM by RT. D is equal to PM by RT. So, for a given gas, for a given gas, D is proportional to P by T. For a given gas, M and R will be kept constant, then D is proportional to P by T. For example, at what conditions neon will have highest density? Neon will have highest density. Option 1 is 0 degrees centigrade, 1 atmosphere pressure. Option 2 is 0 degrees centigrade, 2 atmospheres pressure. Option 3 is 273 degrees centigrade, 1 atmosphere pressure. Option 4 is 273 degrees centigrade and 2 atmospheres pressure. So what is the necessary condition? Pressure must be high, temperature must be low. These conditions will be satisfied by the relation 2. So this is the correct option. For a given gas, when pressure and temperature, when molecular weight and R value will be constant, so D is proportional to by P by T. So at what condition neon will have the highest density? At low temperature and high pressure.